Welcome to Theory of Computation. I am going to give an explanation for the third undecidable problem solution, which comes under MPCP. That means Modified Post Correspondence Problem. So if you consider universal language is an undecidable problem. For an undecidable problem, we can able to write a solution for the given thing. So it is a modified post correspondence problem. Using that, one type of algorithm can be modified into another type of algorithm. So it is a PCP notation. So in a post correspondence problem, there are two lists are given. You should use all the instances of those two lists, and those two lists are same means we can able to find a solution based upon PCP. If you consider modified PCP, the first instance should be starts with 1 only. So that is the clear-cut notation for the difference between PCP and MPCP. PCP does not starts with instance 1. You can either starts with 2, 3 or like that. But in an MPCP, the solution should start with the first string. That is MPCP. So consider the notation. Here 4 strings are available. The instances are 1, 2, 3, 4. MPCP means it should also start with first string. So I am taking first string here. So I is equal to, this is first instance, A list, B list, first instance, first A value is 1, second value is 1, and extra 1 is available. So I can able to write 2 here. 2 means it contains single 1, it contains triple 1. Then again 2. Then it is single 1, it is triple 1. Extra triple 1 is there, but there is no triple 1 at A. So you cannot able to take instance 1. So if you consider the number, you should use all these values here. So I am taking the first instance. I is equal to first instance. A list contains 1, 1. B list contains only 1. Then I am taking the third string. The third string is 0, triple 1. And B list value is 1, 0. Then extra 3 ones are available. So I am going to take the second notation. The second notation is single 1. B value is triple 1. Once again I am taking 2. So it is single 1, it is 3, 1. And if I am taking fourth value, it is 1, 0, 0. So these two strings are equal. So the instances are 1, 3, 2, 2, 4. So if an instance starts with 1, the solution is MPCP. If you want to able to find a solution and the solution does not start with 1 means those solutions are called as PCP. So this is the difference between PCP and MPCP. And there is always a theorem for relating PCP and MPCP. If you want to consider PCP is a decidable problem, then MPCP would also be a decidable one. So this is solved by using Turing machine with a string W. So it is a pair. We should construct a string instance based upon two lists A and B. If you find a solution at A, we can also able to find a solution at B. So M will accept the input W if it should be available in both A list and B list means we can able to find a solution. So how to solve it? We should frame a rule constructions. So there are 5 different rules are available. So totally 5 different rules are available. They are giving, we should frame list A and list B. So we should construct list A and list B. The input is a Turing machine. So the Turing machine contains a 7-tuple representation Q, sigma, tau, tilde, starting state and blank spaces in tape symbol, final state. So these are all the 7 parameters and they will give the input string W. So W is an input string. So they all give it. From that, rule 1 will be considered as the given string with an initial state. We should write list A as only hash. Hash means blank space. So blank symbol, it is denoted as hash. In list B, we should write it as hash followed by initial state, then the input string that should be ending with hash. Second rule, what are all the tape symbols available in list A, we can also write it in list B. Otherwise, vice versa. If list B is extra value, we can also frame those values in list A. So this is second rule. And third rule is framed with the transition functions. So there are 4 different types of functions are possible. One is with right direction or left direction with the given input symbol sigma or blank space. So if it is told of qx equal to pyr, instead of writing qx, we can write a solution as yp. Because instead of q state, we should write p state. Instead of x symbol, we should write y symbol. And we should go to right direction means the opposite value, yp. If it is blank space means q hash means we should write yp. So either the symbol x or hash for right direction, we write the same input as yp. And for left direction, if you want to go to left direction, additional symbol is there, that is z. Before that only we should write the state. So it is written as, instead of zqx, we should write z, left side value is p, and instead of x we should write y. So pzy. Either x can be read or blank space can be read at tape symbols. So these are all 4 different transition functions. And if you consider final state is reached and left and right values contains some input symbols means we just skip one symbol at a time. So x, q, y means we can able to skip the left side value and we can write it as qy. If qy only available means we can skip only one symbol at right side, we can write it as q. And there is no value at right side, only it contains x symbol at left side means we can ignore it. And we can only write q symbol. So here q is considered as final state. So if any final state is reached, we can implement 4th rule. And 5th rule, if q is followed by a single hash, then we can stop the procedure with adding q with a double hash symbol at list A. So at last list A and list B should contain equal values in it. So this is the rule construction. And I am going to explain the solution for the problem with a given example in next session. Thank you.